Okay, so to give you a basic idea of what we do up here in the cockpit, this is my office. It's aircraft 87303, where I live and breathe during all the demonstrations. This is that's where all the magic happens. On the left side here, we've got our throttle, kind of like our gas pedal. Makes us go fast. It basically the way it works is forward is what we call military power, and that's 100% RPM. And then when you want to go really fast and dump a lot of fuel into the engine and make the afterburner ignite, you kind of go, there's a little detent, lift it out, push it forward, and now you're going really fast. So that's the throttle. Interesting feature on the throttle is our smoke system. The way we turn the smoke on and off for the demonstrations is right here with what we call the dogfight switch. We've done a small modification to it to make it actually function with the smoke system. So outboard turns it on, inboard turns it off. So when the boss says smoke on, ready now, it goes out, smoke off, ready now, it goes back in. And it's that easy, so we don't have to take our hands off the stick and the throttle at all to actuate the smoke. Other stuff, the ejection system, the seat, it's an ACES 2 ejection seat. It's capable of what we call 0-0. It's a 0-0 capable seat, which means I could pull the handles right now, and if there wasn't a roof on top of us, I would eject out of this plane and get a parachute, and it's going to work just fine, not moving at all, and on the ground essentially. Okay, so some other features on the throttle. It's got, I think it's 5 buttons on the throttle, 5 buttons and switches. Essentially, again, when you're flying this airplane in a tactical type of profile, you're going to be wanting to work your radar, your avionics, all sorts of buttons and switches that you don't want to have to take, if you're in a dogfight, for instance, you don't want to have to take your hand off the throttle and push buttons up here or whatever. You're going to want to do it on the stick and the throttle. So Lockheed did a great job designing this. Hotas, they call it, hands-on throttle and stick, so you can work the radar, shoot missiles, all sorts of stuff, talk on the radio, all without taking your hands off the stick and the throttle. The speed brake switch, that's how we slow down in a hurry. If we're going really fast, we want to throw the brakes on, if you will. That's activated right here. We've got some big displays here, again, that shows us radar information, some kind of avionics information, stores management system, what's going on with the jet. It's got kind of a crude, some models of the F-16's got sort of a crude moving map display, so I can keep positional awareness in space. Some Thunderbird add-ons, if you will. We've got our stopwatch. Our show is choreographed, very specifically. We've got certain, pieces of comm that we want to hear, and when we hear this piece of comm, I know that 30 seconds later I want to be at this point in space. So during the demonstration, primarily the boss and the 2 solo pilots are beating the heck out of this clock. So we reset it like such, and it's just an analog clock that, no kidding, we use a whole lot during the demonstration. In fact, I've already worn out 2 pair of gloves, and I get a hole right there in the index finger from hitting this reset switch so much. So this stopwatch sees a lot of action. We like to fly with a flag every demonstration. Just kind of remember what we're doing, what this is all about, and who we represent, the American people. And what we do after the show is we go up and in the autograph line, we try to find a little kid that might look excited about what he just saw and try to give him the flag. And I usually say, hey, I want you to take care of this. It flew with me in the jet today, and you take good care of it, and do something special with it. And I'd like to think that child might be influenced and remember that event in his life. That may be a significant thing that may make them, make a career for the military or just be supportive of the military. We got our heads-up display. That's gives us very precise airspeed, altitude information, heading information. There's a pitch ladder that tells me how high, how many degrees nose high or degrees nose low I am. It shows a false horizon line, so we get a ton of information. In fact, most of the stuff that we're doing is focusing, getting all our information out of this heads-up display, as opposed to looking down here at these round dials. The round dials are kind of backup instruments, but we call ourselves HUD babies, heads-up display babies, because we're so used to staring at this heads-up display that if it ever fails, it's a hard transition to get back down to the analog dials, but we can do that if necessary. Over here is the stick. This is the control stick. It's on the right-hand side of the cockpit, which is kind of unusual. Most fighter jets have the stick in between the legs, but as you can see, there's avionics and displays in between your legs here in the F-16. So the stick is over on the right-hand side, and it only moves about 1/4 of an inch in each direction. You know, you can see what I'm doing here is the max travel of that stick. So that's kind of a unique feature of the jet. What makes it cool is, you know, it's very, very sensitive. You kind of just think about the direction you want to move and just apply a tiny bit of pressure and the jet's moving. You're not manhandling the jet around at all. It's just very sensitive, fly-by-wire design. So it's essentially all stick pressure, very, very sensitive. If I want to get the maximum performance out of the tail of the jet, the slab, I'll just pull straight back, and that's going to move those things a whole big distance. And it's about a 25-pound pull back, and I want to say about a 15-pound push forward. In fact, the original design of the F-16, this stick didn't move at all. It was all pressure sensors. But the pilots that were originally flying it didn't like it. You know, they needed that human feedback, so they added that. The engineers added that feature in to give it a little bit of movement, so you kind of can feel what's going on a little bit better. There's a whole bunch of buttons and stuff on the stick here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 buttons and switches on the stick. And again, along with that hands-on throttle and stick concept that the engineers designed into this jet, you can work your radar displays, you can release your weapons, shoot the gun, trim the airplane, you know, to make the flight control surfaces feel more neutral. You can do all that with the stick and the throttle. So essentially on the ground, before you take off, you're working the switches that you see kind of far in the back, these consoles back here. You're going to set those switches and buttons up the way you want on the left side and the right side. And then once you're up in the air, all you're really doing is you're keeping your hands on the stick and the throttle the entire time. And then you're working some of these buttons up here, which are obviously very, very easily accessible, and some of your multi-function display buttons down here. Another thing that's sort of hard to see is the rudder pedals. They're down by my feet here. When I'm on the ground, that's how we steer the airplane, nose wheel steering. We essentially hit a button on the stick here that latches the nose wheel steering system. And if I want to turn left, I press down on the left pedal. If I want to turn right, press down on the right pedal. And then once we take off, the nose wheel steering system is disengaged. Those pedals work your rudder, which as you can see is the big vertical surface on the back of the tail that's going to move it left and right. And that's, again, going to have a big effect on your flight controls.